And same way, if we go for the S32K3 microcontrollers, so S32K3 has it like it. There is also a description of this S32K3, and if you will read it, so you will find pretty much all the things which we have briefed as if now. But S32K3 has certain advanced features and specifications as compared to S32K1. So those are like S32K3 is compliant up to ASIL-D functional safety, and also S32K3 family are based on ARM Cortex M7, and there are multiple cores in a single S32K3 microcontroller. So in that there are configurations of single, dual, or lockstep core configurations in which we can run multiple cores parallelly or simultaneously. And also the S32K3 has advanced peripherals of automotive like Ethernet, automotive Ethernet, and gigabit Ethernet. So one can perform firmware over the air updates on them, and they also have high-end security peripheral HSE. And same way as 32K3 has different microcontroller families further in it. So this is part 1, K310, K311, K312, K314. Then same way, like there are 4 block diagrams, and the features and the differences are these which are stated. So in terms of the features, S32K3 family has number of common features on all the variants, and S32K3 has much more variations in their family as compared to S32K1 family. And the common features which are there in all the family of S32K3 are the HSC-B security peripheral, and then there are peripherals which are present in these microcontrollers: LPUART, I2C, SPI, FlexIO, and these microcontrollers are compliant from ASIL-D as well, and as well as some are ASIL-B compliant. And then the major one of their interesting common feature are the number of peripherals, the type of peripherals. So these controllers have high-end peripherals of flex timer, ADC, triggering mechanisms using body control triggering unit for the automotive applications for via these microcontrollers. And also some of the microcontrollers of this K3 has features of automotive Ethernet, via which we can build the time-sensitive networking applications which are extensively used for high-end ADAS and the software-defined vehicles. And then there are number of advanced peripherals like DAC, sine wave generator, quad SPI, and there are major difference. And the one of the very interesting is the number of cores which are present. ARM Cortex M7, 2, 3 or cores are present running at 240, 320 megahertz and 300 megahertz also. So we will be dwelling much more in detail about these peripheral of the S32K3 via the S32K344 microcontroller by exploring it, as we at Gettobyte have one of our evaluation board, Autoboard version 1, which is built on K344 microcontroller, and there are number of software resources and our blogs also and content on this K3 family on our edutech website. And now if we go further on this, so in this S32K3 also there is a support of S32 Design Studio and MATLAB Design Toolbox, and number of software stacks for getting started with it. Real-time drivers which are both automotive, AUTOSAR and non-AUTOSAR compliant, and then number of middleware stacks like of FreeRTOS, AWS libraries for the cloud connectivity for the telematics applications, and the this Lightning and the HSC, the the security and safety middleware stacks. And now just like in the S32K1 also there are number of hardware boards. So for getting started with the real-time project building and the solutions to be built, NXP also provides number of development boards, evaluation boards on the S32K3 in which all the pins of microcontrollers are being exposed, and then certain number of evaluation boards on the specific applications like for motor control and then telematics, battery management systems, and then there are number of onboard debuggers and reference design board solutions specifically on K3 with respect to BMS applications to be built on. And then there are number of sensor breakouts like for Ethernet, CAN, motor shields, which can be used with these development boards of NXP for the prototyping, development, and building the automotive applications. Apart from this NXP, we at Gettobyte also has made number of hardware kits on the K3 family. So like Autoboard version 1 and certain ECUs also which are coming up on the K344 for the automotive concentric applications. In this video, we have briefed a lot about the automotive microcontrollers specifically of NXP Semiconductors, and I hope viewers have got an idea that how the automotive applications and technologies being built at the semiconductor chip level. We have explored number of software kits, hardware kits, software resources of a top semiconductor company like of NXP. And now in our upcoming video, we are going to explore more such advanced microcontrollers, semiconductor chips of different companies and explore their software resources, hardware kits, and have a proper understanding on how these technologies are being built at the semiconductor chip level.